Hi, I'm Alexandria, and I did my project on the effects of man-made sound on southern kingfish. Southern kingfish are found pretty much all over the Atlantic, American eastern seaboard and through the Gulf of Mexico. They're a fairly common fish. They're kind of on the small size. Most of them are not over 2 pounds, and not very long. They're pretty dark in color. They have like a dark silvery copper color to them, and it's probably due to the fact that they live on the bottom. They're bottom dwellers. So, wait. So this is a southern kingfish. The ones I had were a lot smaller than this, and yeah. How did fish hear? Fish hear through two different ways. Lots of people don't know this, but fish have an inner ear. It's called an otolith. So the sensitivity of how they hear depends on the relation of the otolith to the swim bladder. So fishes with their otoliths closer to their swim bladder will hear better than the fishes with otoliths farther away. They also have something called a lateral line, and this detects motion and vibration that's coming through the water. It's pretty short range, and they usually want the fish. It only reaches out for like 1 or 2 body lengths away from them. So can sound hurt them? The answer is yes, it can. In some cases, it can cause temporary hearing damage, and in some cases, permanent. How people can help with sound is slowly ramping up sound when it's in the water. My question was, are man-made sounds in the ocean affecting the fish population in all ocean homes? And will the addition of man-made sound will cause an increase of gill populations in southern kingfish? That was my hypothesis. So my experiment was conducted in a 10-gallon tank with 1 southern kingfish. I was using this awesome website called the Discovery of Sea Sounds. And they have an awesome sound gallery that has all these man-made and animal-made sounds, and it was run into the tank through a waterproof speaker. I would run the speaker, I'd put the speaker in and then let it run for 30 seconds. My control was no sound with the speaker in, and then I'd wait 5 minutes and run the next sound. And I did this in 12-hour intervals. I used the sounds of a sonar, a large commercial ship, a merchant vessel, a 34 horsepower outboard motor, and a personal watercraft. My results showed a slight increase in gill populations. That was what I was measuring. So gill populations is basically the movement of the operculum, which is basically where the gill is. But it was only a slight increase, and it varied from trial to trial. In some cases, it was like an increase of 2, and then the same sound, there would be an increase of 7 the next day. So it was kind of varied, but the data did support my hypothesis. I think that more trials would need to be conducted for it to actually truly give me a better firm support of my hypothesis. So here's my graph. You can see that the control is right here, and the gill populations usually ran around in the 60s, from like a 63 to a 68. And then the sonar consistently gave me, in my results, showed a higher gill population rate. And then we also have our commercial ship, merchant vessel, outboard motor, and a personal watercraft. Like I said, I ran 3 trials. The tannish one is the first trial, the blue is the second trial, and the green is the third trial. I'd like to thank Greg for being my mentor and letting me talk out problems with him, especially when my fish were dying and I couldn't figure out why. I originally wanted to do this with 5 fish, but I ended up doing it with 1. Marty for helping me finalize my project idea. You can ask him. The first night I was running up to his room, running over my idea with him, and it was a huge help. Samantha for well, Cameron for helping me run my experiment. He was up there with me running the sound while I counted gill palpitations and early in the morning. Samantha for helping me with this PowerPoint, Hannah for everything else, and Shelby for dealing with my freakouts about issues and everything else. Thank you. Any questions? Greg? Greg asked if the sounds would disrupt with fish communication, and I could see how, I don't know exactly, but I could see how it could maybe interfere with their lateral line, because lots of fish use lower lateral line to swim in tight schools with each other. So if a boat was coming through and it was disrupting the vibrations of their lateral line, I could see how that would affect their schooling habits and other things. Any other questions? Kendall? I don't know exactly, but it's just the closeness of it, and in some fish it's connected, but in others it's not. So, any others?